Today I'm going to show you how to solve a challenge question, an extending level one. This one's pretty evil. I made it up. It's based on one of the questions in your review package, so hopefully you understand the first step. You've got this motor here doing a bunch of work on this block to speed it up and make it faster than it was before. First thing we need to do is figure out how much work this thing did. Fortunately, we've got a force displacement graph for the whole thing, and we're going to use it to solve. First thing I'm going to do is I'm going to find the area of this little triangle here. It's 20 times 2 divided by 2, so this will have an area of 20. Next, I'm going to find the area of this bit right here. It looks like it goes from 20 to 50. So easiest way to solve for the area would be to find the average height, which to me looks like 35. 35 is my average height. I'll multiply that by the displacement, which is 1. 35 times 1 is 1. So this whole section right here has 35 joules that was done during it. And then for the remainder, we are going from 3 to 8 meters. So this is a distance of 5 meters. And this is a force of 50 newtons. 5 times 50 is 250. So we just have to add them all up. Our total work is equal to 20 plus 35 plus 250. Equaling a grand total of 305 joules. So that's how much was added. Now, once we've got that, we got to do our whole before equals after thing. Now, the trick is, as it goes up the slope, it was moving at the beginning, and it speeds up by 5 meters per second. So we got to include that in our formula. It's kind of nice that it's only 5 meters per second faster, because that means we can do it with only one variable. So our energy before is going to equal our energy after, as always. Before it was moving, 1/2 m VI squared. We also did a pile of work on it. We did that 305 joules of work on it. So this EK plus work is going to equal EP plus EK. Now, this was frictionless, so we don't have to worry about any thermal energy being generated or negative work done by friction or anything like that. So we'll just do our mgh plus 1/2 m VI plus 5 squared. At this point, it's basically just math. We've got 1/2 times the mass is conveniently 1. So we've got 1/2 times 2 is just 1. So we've got VI squared plus 305 equals 2 times 9.8 times 10.6. Plus 1/2 times 2, which is just 1. So we can basically ignore that because it's just 1. So we just got to kind of FOIL this through. And that will end up being VI squared plus 10 VI plus 25. Notice our VI squareds, we got one on the before side and one on the after side, so it just cancels, which is delightful. And then we just got to do math and solve for the rest. And that's the trick. Big thing with this one is you got a force displacement graph. Force times displacement is work or change in energy. Find the area under the graph. That will be that thing. And then just set up your equations with before equals after. It looks like you've got 2 unknowns, but really you don't. Just plug it into your before equals after, and really just do some math. So at this point, not too hard. We kick the 205 to the other side, math this out, figure out what that is. And we're done. So that is how you solve it. Hopefully it's not too bad from here math-wise. I could do it quick. Feel free to turn this off if it makes sense at this point. So this is basically 208. If we subtract that from both sides and 25 from both sides, we end up with 72. So we got 72 equals 10 VI, and so VI is just 72 divided by 10, or 7.2 meters per second. Anyway, hope this was helpful. Remember, just kind of set up the formula. Realize what kind of energy you have in the initial situation and what types of energy you have in the final situation. Just make them equal to each other. That's the big trick. Hope this helped.